Hello and welcome to Life Science and Technology series. Today's topic will be biology labs. I'd like to start with what was one of the main resources for the industry when life science labs, became really prevalent in the world of pharma and then R&D. One of the government agencies that helped support all the rules and regulations that helped make those spaces safe was the CDC and NIH, and the BMBL, Biosafety, Microbiology, and Biomedical Laboratories Manual is one of the key documents that helps define what you can and can't do inside of various labs. It starts with the biosafety level hazards, and it starts with biosafety level classification. So there's a BL1, which is very light level. You can do anything open on a bench. The BL2, where you have to, in general, have to have hand sinks. You have to have protocols for pressurization of those rooms. BL3 is a higher level of hazard where you have to get approval from the CDC to use those biosafety level 3 agents in research and development. And those spaces you have to keep negatively pressurized all the time. So even when a fan fails, you need to make sure that you have the controls and the fan system's reliability, redundancy on the emergency power and the control system to maintain a negative pressure. In the BL3, the exhaust side HEPA filters are optional. Most people put them in because it's a best practice when you're relating your building or your lab to a neighborhood or even a commercial area where there's other people in the vicinity. A BL4 is a lab where the agents are that much more dangerous. And generally speaking, you are in an air suit. It's almost, you could equate it to being inside of a submarine. There's submarine doors of very high pressure, very tightly controlled, and everybody's wearing a full breathing suit for safety. And those are all HEPA filtered on the exhaust side. Some of the things you need to know are that they need to be negatively pressurized. So when you have a negatively pressurized space, you have to have control over the airflow. You need to have airflow valves. You need to be able to control those in a positive or negative way, depending on the space that you're working in. Some spaces are clean spaces. Some spaces will be HEPA filtered, in which case those rooms want to be positively pressurized. And you'll find that maybe an adjacent lab on that same corridor needs to be negatively pressurized. So the ability to control pressure is very important. The ability to manage the airflow is very important. And in some cases, a hard requirement for cross-contamination. You need to be very careful with recirculation of air when you're worried about bioburden, which is the cross-contamination from one space to another, or even from one area of a lab to the other side of the lab. So it's very important to control airflows and air currents using things like radial flow diffusers, making sure you have good airflow and appropriate zones for specific pieces of equipment. In the equipment world, you can be looking at a lot of different things. Biosafety cabinets come in many different categories. Some are exhausted, some are not, some are partially exhausted. It's good to know that in the case of a biosafety cabinet, they are specifically designed to protect the sample inside of the biosafety cabinet, not the user. So you're really protecting the sample from the people that are manipulating it. The other big pieces of equipment you're going to run into in biology labs, you're going to see things like fermenters and bioreactors and incubators, shakers, refrigerators, freezers. There's a large quantity of equipment, a lot of things that require exhaust, a lot of devices that require a lot of heat rejection. So you're driving very large HVAC systems. Important to note too that you're going to run up against a lot of pure water systems. Many of the biology labs are going to have pure water systems anywhere from reagent grade water to USP water to water for injection. So there's a lot of water systems that you could experience and come up against in those spaces, as well as piped gases. They could be cylinder gases where you have manifolds in the space, or they could be bulk gases where they are piped from a gas yard. All these things can be challenges, and it's good to understand the importance of all of that criteria when you're looking at a building or you're helping a tenant understand what buildings may be viable for them. I think the biology side of what we're doing is really, really hot right now due to all of the flow of capital that's gone into life sciences and research for health benefits, mostly related to and caused by COVID. But excited to see how that's going to improve our health and society going forward. That's all for now. Looking forward to the next segment. Thanks.